Okay, so the other thing we can do when we have small sample sizes is we can, instead of combining columns, run what's called Fisher's exact test. So the advantages of doing Fisher's test is, well, it's called exact because you can find the exact p-value, not an approximate p-value, which is all you get out of the chi-squared test. Hence, it gives you more accurate results. There are some disadvantages to Fisher's test as well, though. Fisher's test is very complicated. The calculations required are extremely difficult. And they're so difficult that this test is not even yet widely implemented in your statistical software packages. Like in our case, StatCrunch can only handle it with a two-way contingency table. So there are larger Fisher's tests that can be run, but the calculations are so complicated that even StatCrunch can't handle them yet. So it's not that I don't think we'll ever get there, but we just aren't there yet. So definitely, if you think 10 or 15, 20 years ago and people were doing this by hand, that was the only option, Fisher's test was not always an option because the calculations were so difficult. Now it's starting to become more of an option. So we're going to use it in the cases where we can use it so that we'll get more accurate results. Let's revisit that idea of, I think this was maybe in the very first week, I think we might have talked about this, but children suffering from non-lethal scorpion stings. So kids got stung by a scorpion, but it wasn't so severe that they were going to die from it. But so these kids were randomly assigned to receive either an antivenom or a placebo, and after several hours, the investigators recorded whether the children showed some kind of improvement. There were 15 children in the study, and the summary is as follows. Okay, so this is a very small sample size. 15 is very small overall. So it says, could the seemingly favorable outcome of the antivenom simply be due to chance? So look, out of the antivenom kids, 8 total received it. 7 out of the 8 got better and only 1 didn't. And then out of the placebo group, 7 got that. Only 1 of them got better and 6 didn't. So it looks as though, just by a glance, that we would want to say, yes, the antivenom is working. But this is such a small sample that maybe this was just by chance. Maybe if we did this over and over again, this is not the same thing that we would see over and over again. Okay, so we want to see if we've got an association going on or not. So I'm going to claim for my null that the antivenom and the improvement are not associated. And I am going to alternately say that maybe these two things are associated. Okay, so here's a little bit of background into what does Fisher's test do, and this is why you'll see quickly why this becomes very, very complicated. So what Fisher's test does is it imagines a parallel world similar to but different from the world in which the researchers were observing. So the parallel world in this case would be similar because it would also have the same overall total of 15 children with scorpion stings. 8 would receive the antivenom, and 8 would improve. Okay? It's different, though, in that we know for sure in this parallel world there is absolutely, without a shadow of a doubt, no association between the treatment and the outcome. And the results are completely by chance. So it says if you happen to randomly then have 4 of your antivenom receivers get better and 4 of them not, your chart would look like this. And at this point, there's only one way you can fill it in to make the numbers work. If this is still 7 over here, then this would have to be a 3, and then this number would have to be a 4. Right? So it's different. These are not the same results that we just had. Even though all of the totals, basically, all these numbers out here were the same, they rearranged these numbers. So again, we could keep all of these numbers the same and rearrange these numbers this way and make it work. Or we could keep them the same and rearrange it this way and make it work. And if it is truly completely by chance, then any of these is equally likely, right? So some of these parallel worlds would suggest that the antivenom is successful and some don't. So mathematically, what happens behind Fisher's test, what's going on, is that the p-value is being calculated by figuring out the probability of each table in the parallel world, finding a probability for this table and a probability for this one and a probability for this one up there, finding a probability for each one of them, and then calculating the probability of getting an outcome as extreme or more extreme as the 7 out of 8 improvement that the researchers saw. Okay, if I've lost you a little bit, that's okay. Basically, all I want you to get out of this is it gets really complicated. There is a lot going on. Every possible parallel world scenario has to be taken into account, and so kind of snowballs out of control really quickly. So even StatCrunch will only do this for 2x2 tables so far anyway. Okay, let's go ahead and move on. Lucky for us, we do only have a 2x2 table here. So we can use StatCrunch to perform Fisher's exact tests on the original data with a significant level of 0.05. Okay, so the difference is now when we go to, let's go to our StatCrunch, and I need a new StatCrunch here. And what do we have? We have, let me write that table in. We had no improvement and improvement. And we had 1, 7, 6, 1, and this was antivenom, and this was placebo. Okay, and that's all I need. I can now go into my stat tables contingency with summary. So I go in as if I'm running the test for independence. I still choose my columns, choose my label. The only difference is I come down here and instead of the default test for independence, I pick the next one down, which is Fisher's exact test for independence. Notice it does tell you it will only work for 2x2s, and then I can compute it. There is no test statistic for Fisher's exact test. There is only a p-value, which is all I need to draw my conclusion anyway. So since I guess that's all I need to record is that my p-value was 0.0101. So since p is less than 0.05, reject the null. The null was that there was no association going on here, so we conclude that there is an association between the anti-venom and improvement.